Namaste guys, myself Varshini Gondkar. Okay, now whenever you search in YouTube for ninth class Karnataka board, you may get very few YouTube channels. And there too you don't get LBA questions, some previous year questions, right? So in this tutorial, you will be getting all of those. And today we will be starting our ninth class mathematics, okay, with the first chapter, that is. Okay, see, this is ninth class, and we are going to do completely, okay, completely based on our Karnataka board, and I'm going to completely cover NCERT 9th standard. Okay, so the first chapter is number system, correct? Okay, so before starting every chapter, the first question in your mind should be, why are we learning this chapter? Isn't it? So when you were little kid, okay, you were taught numbers. So today, if your best friend, if it is your best friend's birthday, so she distributes the chocolates, she or he distributes the chocolate to the whole class, each chocolate for each one. But because he or she is your best friend, will give you two chocolates, isn't it? So you ask, you should give me two chocolates. So two is a number, three is a number. So all these numbers. Now this is mango season. So if I give you so many mangoes and tell you to count them, so what do? You start counting them. So numbers are useful for counting basically. But here we are going to do with number system. So what are these numbers? What is this number system? what what do we have in this number system? Let's start. So the first is that when I tell you, as I told you before, you have mangoes, some mangoes in front of you, and you must count them. So what do? Do you start from 0, 1, 2? No, you start from 1, 2, 3, right? So we naturally start from 1, 2, 3, and that's why the first uh, type is our natural numbers. So what are natural numbers? Which we start naturally. That is, we start from 1. Okay, but you cannot tell the definition like this in front of your teacher, or you cannot write the same definition, the whole explanation in your paper. So you need some kind of definition. Okay, so the definition is, natural numbers are the counting numbers we use in everyday life. Okay, that we start when we start counting, we start with now a natural number. Okay, for example, 1, 2, 3, 4, 5, and so on till infinity. Okay, so what is infinity? Infinity means there is no end. Okay, numbers don't have end. There are infinite. Infinite is nothing but the which does not end. Okay, now next is, okay, now we one to the natural number starts from 1 to 3, but we also have a number called 0, isn't it? That is also part of our number system. So if I start from 0, 1, 2, 3, you may ask me a question, Akka. If I start from 0, 1, 2, 3, then what will we call it? We cannot call it as natural number because we have already called these numbers as natural numbers. So for that, we have given the name as whole numbers. Why whole? Whole. What does whole mean? Whole means full. So we are even including 0 and we are telling it in whole, right? So we are going to tell it in whole. That's why we are going to call them as whole numbers. Once again, this explanation you cannot go and write in the paper. You need some proper definition, and for that proper definition I have here, whole numbers are the collection of all natural numbers together with 0. Means, along with natural numbers, what do we had? 1, 2, 3, 4, 5, 6. Along with that, we're going to add 0 behind. So 0, 1, 2, 3, 4, 5, 6. If it starts from 0 till infinity, then it is called as whole numbers. Okay, see, 0, 1, 2, 3, 4, 5 till infinity. Once again, infinity means which does not have end. Next, okay, now we have whole numbers. What if you have 5 mangoes with you? Okay, and if I give you 2 mangoes, How many mangoes will be left with you? 5 plus 2, that is 7. But now, okay, leave it. Now I did not give you 2 mangoes. You have 5 mangoes. Instead of giving you 2 mangoes, I took 2 mangoes from you. How many are left? 5 minus 2, that is 3. So 3 mangoes are left to you with you. Now, how will you tell this? How will you tell this that I have given 2 mangoes to Akka, right? So if I give you 2 mangoes, you will tell, oh, plus 2 mangoes are I have with 5. I have plus 2. But if I take from you 2 mangoes, that is from you, if I take 2 mangoes, so you were having 5 mangoes. Now you gave me 2 mangoes. How many are left? 3 are left. Now how can you tell that? Then you were telling plus 2. Now we have to tell minus 2. Right? Okay. Now think, one there was a car which was moving towards right. Okay, towards right it was moving with think it was going with a speed of 20 meter per second. Okay, 20 meter per second. It was covering the speed of 20 meters in 1 second. Okay, it was moving. So you told it as 20 meter per second. What if the same car turned this side and started moving towards left side? So at that time you have to tell. You cannot tell it is moving with 20 meter per second. You have to give it something that which will indicate that it is moving towards left now, not right. Right? At that time we use negative numbers. Negative indicated that before it was in this direction, now the direction is opposite. Right? So that's how important these negative numbers are. Now if you tell upward 10 meters per second, then how will you indicate downward? With a negative number, right? Because that is opposite to this up. Down is opposite, so you need negative numbers. Or else simple, you had 10 rupees. Next day you went, you earned more 5 rupees. You earned means you got profit. So you tell 10 plus 5. But next day you did not earn. Instead, you bought your favorite teddy bear. Okay. So what happened? Think, okay, it is not that very cheap. Okay, let me take kurkure. Okay, kurkure, 5 rupees kurkure. You had 10 rupees. You gave 5 rupees. You took kurkure. So you had 10 rupees. Now 5 rupees went away from you. That is, you lost 5 rupees. Okay, you're in loss now. How will you tell it? You will tell minus 5. I had 10. Now it is minus 5. 5 went and I have 5. So 10 minus 5. So minus 5. So you need some negative numbers. Now how will you? Now we cannot tell it as a natural number. You can tell it as natural number, neither whole numbers, right? Then what will you call it? Okay, so before that I have some important points for you for natural numbers and whole numbers. See, nn is nothing but natural numbers. Okay, so natural numbers are positive whole numbers. Okay, they are natural numbers are nothing but positive whole numbers. You have only positive whole numbers. Okay, 1 2 3 4 5 6, and they do not include fractions. In whole numbers and natural numbers you don't have fractions. Okay, coming to positive and negative numbers, both together we have termed it as integers. Okay, integers. Integers are the collection of all whole numbers. What are whole numbers? Which starts from 0, 0, 1, 2, 3 till infinity, and they are negative numbers. Means if 1 is there, then negative of 1 is minus 1, 2, minus 2, 3, minus 3. Okay, so you have here minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Right? Now you may ask me, Akka, why there is no minus 0? Well, this question should not arise, but if it is arise, then let me tell you. 0 means neutral. 0 means nothing. You don't have anything. 1 means you had 1 mango. 2 means you had 2 mangoes. Okay, minus 2 minus 1 means you had one mango, I took one mango from you, so minus 1. Now nothing is there with you. Nothing is there with you. You're just sitting nicely, calmly watching TV, okay? You don't have anything. If you don't have anything, can I borrow from you anything? No. Can you give me anything? No. Can I give you? I can give you, but can I take anything from you? No. Means because you're khali. Okay, you are khali basically. You don't have anything. You're empty. That means I cannot even tell minus, is it minus or plus? Is it negative or positive? Because you don't have anything. So that's why there is no minus 0. 0 is nothing but neutral, nothing. Okay, so 0 is neither positive nor negative. Okay, moving to the next. Okay, now you learnt about negative numbers, positive numbers, whole numbers, all these. But what if I include fractions? Okay, what if I include fractions? So you have learned what are fractions, right? 4 by 2, 8 by 6, 9 by 2, all these. Along with these negative numbers, positive numbers, I'm going to add even fractions. If I add fractions towards positive numbers like 2 by 3, 8 by 5, all these, I have to even add towards negative also. If I add here, okay, here if I add plus 2 by 3, plus 4 by 3, all that, okay, here if I add positive fractions, I have to even add negative fractions, right? But we cannot call it as like negative fractions. Fractions are always positive. So we term all these set numbers, okay, minus 4 by 3, plus 2 by 3, all these as next. Yeah, I think I've forgotten something here. See, so yeah, integers are denoted by z, okay, and in your NCERT you have the reason why we call it as z. Okay, see, z comes from the German word that is zahlen. Zahlen means to count. Okay, that is why we denote it by z. Okay, now coming back to this thing, if I include all the negative fractions and positive fractions, 0, everything, it will be called as, yes, rational numbers. Many of you have guessed, I think. Good if you have guessed it. So rational numbers are the numbers which can be written in P by Q form. Now this definition becomes important for your exam point of view, so remember it, okay? Rational numbers are the numbers which can be written in the P by Q form. Means whatever number you take, you have to be able to write it in the form of P by Q. Means in the fraction form. Okay, if I take 2, then you can write it as 2 by 1. You can write it as 2 by 1. Whatever number you take. 4 by 3, if you take 4, only 4, then you can write it as 4 by 1. So that is also rational number, right? But there is a condition. What is the condition? Where P and Q are integers. P and Q must be integers. Okay, means it can be negative numbers, positive numbers. Okay, and q, the denominator should not be equal to 0, or else the number becomes undefined. Whenever you get 0 in the denominator, the number is undefined, guys. Okay, so we don't keep these in the denominator. Okay, you will learn in first pu and second pu some of the undetermined numbers, all those things. Okay, so for now we will just understand that the denominator things cannot be 0, or else it will be not defined. Okay, uh, so all now I'm going to give you an NCERT line which says rational comes from the word ratio and Q comes from the word quotient. Now we are telling it as rational numbers. Rational numbers, why? Rational comes from the word called ratio. Ratio means what? Whenever we are writing ratios, we always write them in fractions, isn't it? So from that word itself, this rational has come, like 2 by 3, 4 by 2, all this. These are called as fractions. They are called as ratio, right? So that's why. And Q comes from the word quotient. Okay, quotient. When we divide a number, what the last what we get, that is called as remainder, and answer what we get, that is called as quotient, right? So that is only quotient. This is an NCERT line, so that's why I just brought it. Now for let's see some examples for rational numbers so that you'll get a clear idea. Okay, you'll get a clear idea. See, one is a rational number, of course, because you can write it in the form of p by q form, right? See, rational numbers are those numbers which can be written as in the form of p by q, right? So can you write 1 as p in p by q form? Of course, 1 by 1, 2 by 5, 8 by 7. Now just observe, minus 2 by 5. Okay, minus 2 by 5 doesn't come under fractions, it comes under rational numbers. Okay, because fractions cannot be in negative, but rational numbers can be negative. Next, minus 13 by 8. Okay, these are some examples for rational numbers. Okay, here is some of the example questions from your NCERT. See, example questions are actually very important for you. Are the following statements true or false? Give reasons for your answers. Actually, answers are given in your textbook. Okay, but you need some explanations, isn't it? That's why I have brought it. So every whole number is a natural number. Is it true or false? Just pause the video for some seconds and think yourself, answer, and then see what's the correct answer. Okay, I hope you have paused the video and now you're starting. See, if you don't pause the video, don't think yourself, see, you'll not learn. Okay, that's the thing. You have to pause the video, think yourself. When you think, you get some thoughts about these things, right? Well, these are simple questions. In upcoming classes, when the level of question increases, okay, then I'm telling you. Well, so every whole number is a natural number. Is it true, guys? Just think. Is every whole number is a natural number? Is it true? No. Why? Because whole number starts from 0, but natural number does not start from 0, right? So if I tell every whole number is natural number, every whole number, ella whole number kuda natural number anta, if I assume, okay, if I assume, then what about 0? Right? So 0 is not a natural number, it is a whole number. That's why this statement becomes false, right? Next, coming to the next thing, every integer is a rational number. Is it true? Of course. See, just think, a rational number is a set of all numbers, natural number, whole number, and integer. Is integer inside the rational number? ಈಗ rational number ಅಲ್ಲಿ you have natural number ಇದೆ, whole number ಇದೆ, integers ಇದೆ. For example, let me take, there is a plastic. Okay, there's a plastic cover. You have Melody chocolates in that, you have Milky Bar chocolates in that, and you have Dairy Milk chocolate. Okay, Dairy Milk chocolate, Milk Bar, and Melody. Now if I ask you and let me name that plastic cover as Cadbury, okay, something, okay, Cadbury, I'll name it as Cadbury. Is Melody belongs to Cadbury? Yes, actually it does not. Okay, in real life, you know, and I know, it is actually Parley companies, but I'm just giving it as a name, or giving it name as Cadbury. In the Cadbury plastic, does Melody contain, is Melody inside the cover? Of course. Is Milky Bar is inside the Cadbury? Yes. Right. In the same way, in Cadbury, in rational number, Cadbury means rational number. Integer, think it as Melody. Or else let Melody be this natural number. Okay, Melody means natural number. Okay, just assume. And this 5 rupees, what you get, Dairy Milk, think it as whole number, and 10 rupees Milky Bar, which is more bigger. Okay, that assume that it as integers. So in Cadbury, all these three are present. So you can tell every melody is Cadbury, yes. Every Milky Bar is Cadbury, yes, because it is inside it, right? Now, if I tell it as the rational number, and if I tell is every integer rational number, yes, your answer should be yes. That's how it works, guys. But if I ask you counter question, which is next, so this is true, of course. If I ask you counter question, if every rational number is integer, no, because see, in a rational number in Cadbury, you even had Milky Bar, you even had Melody, you even had Dairy Milk. But integer, which is our Milky Bar, does it? You can you tell that Melody is equal to Milky Bar? No, Milky Bar is something different chocolate, and Melody is something different chocolate. In the same way, can you tell integer is same as fractions? No. That is why every rational number is not integer. Every integer can be rational number, but every rational number cannot be integer. That's why this statement becomes false. I hope you understood. If you don't, please comment below. I'm there to answer your question. Okay. Moving on to the next. Okay, there is a question. Find five rational numbers between 1 and 2. Before this, let me tell you a remark given in your textbook. So there's a remark. There are infinitely many rational numbers between any two given rational number. Means here it is told find any five. Okay, find five. So between 1 and 2, see, there are infinitely many rational numbers between any two given rational number. Like if you take 1 and 2, between 1 and 2 you have infinite rational numbers. Okay, this is a true fact, guys. Okay, if this question is asked to you, how many rational numbers are there between 1 and 2, or any two rational numbers, your answer should be there are infinite rational numbers. Okay.